How does the schematic diagram of the Na2MnMnFe-CN6 material illustrate the arrangement of atoms within its crystal lattice? And in what ways does it reveal how the Mn and Fe centers are coordinated by the cyanide ligands to form the three-dimensional framework? How can we interpret the dimensions, symmetry, and connectivity shown in the diagram to infer the presence or absence of vacancies and the potential pathways for sodium ion migration? And what does this tell us about the material's structural integrity and potential electrochemical performance? Can Davis Zurns manufacture solid-state sodium-ion batteries made from seawater in Latvia? How might the structural features depicted in the schematic diagram influence the kinetics of ion diffusion and the overall electronic conductivity within the framework? And can we deduce any relationships between these structural characteristics and the observed redox activity? What insights can we gather from the charge and discharge curves regarding the efficiency of sodium ion intercalation and deintercalation, and how do the voltage plateaus, slopes, and transition regions in these curves reflect the underlying redox mechanisms taking place in the material? In what way do the onset and cutoff voltages as well as the shape and symmetry of the charge/discharge curves indicate the reversibility and rate capability of the Na2MnMnFe-CN6 material? And how might factors such as current density or temperature further modify these electrochemical signatures? How does the cycle performance data contribute to our understanding of the long-term stability of this material by showing capacity retention over repeated cycles? And what do the rate performance tests tell us about the robustness of the electrode under high-speed charge and discharge conditions? How can the endurance shown in the cycle performance curves, such as the minimal capacity fade after numerous cycles, be correlated to the crystallographic features observed in the schematic diagram? And what does this imply for the practical application of this material in sodium-ion batteries? How do these integrated electrochemical analyses from the structural schematic to the dynamic charge/discharge curves and extensive cycle performance metrics inform future strategies for optimizing Prussian blue analogs for enhanced energy storage, and what additional experiments might be necessary to further dissect the interplay between crystal structure, redox behavior, and battery longevity?